This screencast illustrates how to write the equation of a line in a point-slope form when given a point and a slope. So here's my point, here's my slope. The point-slope formula is y minus y1 is equal to m times x minus x1. Basically, the y1 stands for the y-coordinate of the point, and the x1 refers to the x-coordinate of the point, and the m refers to the slope, right here. So when it comes time to write the equation of the line, I'm going to write y minus the y-coordinate of the point is equal to the slope times parentheses x minus the x-coordinate of that same point. So it's going to be x minus a negative 2. We don't really neaten this up, or we don't have to get y isolated. We could, but we won't. But I do minimal cleanup. If I see the x minus a minus 2, I take the minus a negative quantity and I change it to addition. But beyond that, I don't do any real neatening up of the equation. That's a perfectly fine equation just the way it is. Looking at example 2, I've changed things up a little bit by, instead of giving you a point and a slope, I gave you 2 points. The trick is you still need a point and a slope. So since I have no slope, I would begin by calculating it. y2 minus y1 all over x2, which would be the 2, minus 6. And that slope comes out to be 9 over negative 4. So my slope is negative 9/4. And now I have my slope. And I have plenty of points. I really only need 1 point and a slope. It doesn't matter which of those 2 points I choose, so I'm going to just arbitrarily choose that one. And I'm going to use my formula. Y minus y1 equals m times x minus x1. As I plug in my point, y minus the y-coordinate of the point that I've chosen is equal to the slope, negative 9/4, parentheses, x minus the x-coordinate of that same point that I chose. And that's a perfectly good answer. I could have just as easily used this point right here instead. If I had, I would have written y minus, and I would have chosen the y-coordinate of the other point is equal to the slope. The slope is the same, times x minus 6. When I clean it up a little bit by taking care of the double negative, I get this. And even though this equation looks different from the other form, from the other one that I boxed up, it's really just 2 completely correct and equivalent equations, and I don't care which one of these you give me. For example 3, I don't really have to attack it any differently. I'll still go through the same process, but do you notice that when I go calculate the slope, y2 minus a minus 1 all over 3 minus 7, this double negative right here turns into a plus sign, and then I end up with 0 over negative 4. Perhaps you got 0 over positive 4 if you chose the points in the reverse order. And if you remember right, 0 over anything is 0. So this slope came out to be 0. That's my slope. So now, when I write the equation, I can go y minus I can choose either of my 2 points. I'm going to just choose this one. Y minus a minus 1, and that ends up being a y plus 1, right, is equal to the slope times x minus, and then since I chose that point, I'll use the 7. Do you see that 0 times anything will just make that whole side simplify to 0? While I don't make you get all your equations and solve for y form, because 0 time things cleans up so significantly, this one I will choose to leave solve for y. And we get this equation right here. Now, you might wonder why this one behaved that way. The point 7, negative 1, is right about here. Over 7, down negative 1. And then the point 3, negative 1 would be right about here. Do you see that these 2 points have the same height? And that's what makes that line horizontal. When 2 points share the same y-coordinate, then they both have the same height, and it makes the line be horizontal. Anytime a line turns out to be horizontal, this 0 will go here, and it'll cause that whole side of the equation to simplify down to being a 0 every time. So we'll be able to put this equation in this form: y equals some constant number. Horizontal lines have itty-bitty little equations like this. Let me make a point here. You see up here in the original problem, if I had noticed right from the start that my 2 y-coordinates were the same, look how quickly I could have gotten to this equation. Basically, whenever both points are the same height, that forces all of the points on the line to be that height. So this equation right here is just y constantly stays equal to a negative 1. So that's often what will happen with a horizontal line. If you happen to notice that y is unchanging, you can go right to this, right at the beginning. You could just say y equals a negative 1, and that is your equation. If you would rather write it like this, right here, that's okay too. But I would like you to clean it up a little bit so that eventually it says y equals negative 1. Finally, I have this fourth example. And if I do a slope calculation, I end up getting 10 minus a minus 3. Minus a minus ends up being plus. And if I went 10 minus a minus 3, I now have to go 5 minus 5. And I end up getting 13 over 0. And if you recall, anytime you have a number over 0, you don't actually have a number there. 13 over 0 is what they call undefined. It isn't even a number. Whenever that happens, even though the line doesn't have a slope, the slope is undefined. With this example, if I have this equation, it won't be of much use to me. Because remember, I'm supposed to put the slope in for m right here. The problem is this isn't even a number. Since that's not even a number, there's no way to put something in place of m. M is designed to hold the slope, and there is no slope in this case. So this is an example that we actually can't use this formula for. What we can do is we can notice that right here and right here, the x seems to be unchanging. If you were to look at a quick graph of this, 5, negative 3 might be over 5 and then down 3. And 5, 10 would be over 5, but up a whole lot, up 10. And you can see that that creates a vertical line. And the thing that vertical lines all have is they have every point here on this line has the same distance over. No matter where I point on this line, every point is 5 units over. So that's why the equation for something like this is just x is constantly staying equal to 5. That's the entire equation for any vertical line. It's always going to be x equals some constant number, and that constant number will be how far over that x is. So anytime you notice that the x's are unchanging, you can just go immediately to this if you notice. If you don't notice, when you go calculate the slope, you'll notice something peculiar happens and you have a 0 on the bottom. So that's your big hint to go back over and look at the original ordered pairs. And then you should notice that the x's are unchanging and that this ends up being the whole equation. So just to recap, when somebody asks you to write the equation of a line, you're most likely going to use this equation. Where you're subbing out the x1 and the y1 with the point on the line, and you're subbing out the m with the slope. In the case of a horizontal line, the equation is just going to be y is constantly equal to some number. And with a vertical line, the equation form ends up being x is constantly equal to some number. We only use one of these in the special case where the slope comes out to be 0 or undefined. So if you do a slope calculation and neither the top nor the bottom of the slope fraction comes out 0, then this is the baby you're going to use right there. So make this equation your friend and learn how to use it. I hope this video was helpful.